Hi, welcome to another video on my Raspberry Pi with fischertechnik motor, pulse width modulation and some electronics. You will recognize it, see a change if you have watched my previous videos, and that change is caused by a different laptop which I use, full HD screen, and that means that the Tiger VNC is now running in in a much larger resolution, within a much larger resolution. So I could do full HD or full screen, but that means I can't switch between other applications, which I do need to be able to. So I have enlarged it so I can switch, and this is about what you are going to see, apart from camera parts. Last time I came to the conclusion that once again pulse width modulation on hardware with direct memory access does not work, not the way I had hoped it to see working. And I went back to the original, to the first way I had implemented in hardware when using software pulse width modulation, which implies using an op amp and using a pot meter. And the point is that, as I mentioned before, the pulse width modulation control, when you use the fischertechnik power controller, is different from what I do. Different in voltage mainly, and that is something odd. Well, odd, maybe not odd, but different anyway, because as mentioned earlier, the power controller works on 9 volts, so does the motor, and so does nearly everything which is fischertechnik. However, the Raspberry Pi 1 and 2 anyway, 3 probably as well, but I don't have that one, supply 2 voltages, 3.3 volt and 5 volts. Now I had the intention to use an op amp, which I use, by the way, to amplify the voltage. However, I am using a wrong type of op amp to do that. What I found out was that I had to use 741 or 471, whatever, but I don't have that type of op amp. So that is a problem. And when I want to use the motor now and to regulate the to control the motor, I have only the pot meter to my disposal to change the rotational speed, rotational velocity, and it doesn't matter, unfortunately, if I run this pulse width modulation program. If I don't use it, the motor runs, and if I do use it, the motor runs. It doesn't matter. With that, There's another problem as well. With other boards I can adjust the frequency easily, but how can I do that with the Raspberry Pi, considering that neither RPIO pulse width modulation, neither wiring PI pulse width modulation is apparently working. It's using DMA. So by lack of a nice op amp to boost my to amplify my voltage to 9 volts, I have to find another way. So I can do this with a maximum pulse width of 1999, but it won't work. It doesn't do anything, not in my case. And with that, I'm going to find a little bit further. A little search showed a very different approach using this same kind of pulse width modulation, hardware pulse width modulation. So I am going to change my code accordingly. What I need to do is, first of all, remove this part, keeping the while. I still want to use the accept, but I have a while here as well. So let's see which one is best. This hasn't worked so far, neither has this, but I do need to clean up. So this one, no, exactly the wrong way, comment out. Alright, then I am saying that let me call it a new PWM is GPIO dot I have used already PWM, so I can use PWM anyway. 17 comma, and in the example it says 100. I'm going to do something else, 150. Then I say dot start at 0, and I make a small mistake here. This needs to go here, and then the while. Then I say right, let's say speed is input value and then I say new PWM dot change duty cycle. Speed So now my program is a little bit different than the example, but the idea is the same. And then I need the stop, and that's about it. No, it's not. This is a good one. The example says GPIO cleanup. Let's just see whichever works. I'll let this be. No, that is C. This is Python. So and now the question is whichever works, but the point is the motor is now completely set up for using the op amp and the potmeter, and I need to do it using the either completely and only pulse width modulation, or via the transistor, and I'm going to try both. So saving, doing unexpected indent. Oh, that's interesting. Yes, that is a while that I need. Module object is not callable. Line 20. Alright. GPIO dot. Is this better? Not. The channel is invalid on Raspberry Pi. Now that is interesting. That's very interesting. I think that should be RPIO then. And RPI. But I have used here PWM, so I should be even using this one, because I've already imported PWM. Alright, I need to dive into this and change the circuit. It is time to change the setup. So now the motor is dependent on output of the op amp, which has no use because it doesn't amplify the voltage as I explained before. So what I'm going to do now is taking this one out and taking this one out. Make the gap, and then this is pulse width modulation, so I am going to take one, put one in here, and the other one in here. So now it is going via pulse width modulation. Question is, will it work? Well, there's only one way to find out. Start a new program. And you see it doesn't do a thing. And that is quite a big problem. Now this all works. This doesn't, but this LED works. Does this LED work? No, right now it doesn't. And this LED doesn't work either. So does this mean that this is not going to work? I don't know. What I still can do is put it straight on the pulse width modulation. So right now I am putting this one here and putting this one in here, and see what happens now. Alright, maximum value, and it goes out. Oh, it reaches from 0 to 100. And it doesn't do a thing. So that is a negative for this attempt, unfortunately. Now the original program doesn't say what voltage was applied, but since this LED isn't working, the voltage will be absolutely minimal, if at all. So yeah, I'm afraid that is a problem. I need to apply voltage, and there's one way to do so, which is using this one as well, setting it on a speed and then using it anyway. So this is the output. This is pulse modulation, and then I need to apply the pulse modulation also to the motor. Right now it doesn't do a thing. As you can see. So I need to reapply a few things. But then again, I will probably returning to the same position I was in. So what use is it? I need to find out more, in short. The motor has been restored to the op-amp circuit. So I have power around 5 volts. Last time I measured it was 4.5 to 5 volts. The pulse width modulation has been applied as well. And then I look at the code and I realized I made a mistake. And that mistake was this. These two lines I had in the while. This is the while, and this line, the stop and the cleanup, are no part of the while loop. So let's see how that works out. Also, what I also had to do was use the PWM of the GPIO. So does it mean I am actually using soft GPIO or hard GPIO? soft pulse width modulation or hard pulse width modulation? It is both PWM. So that's a good question. Here I use obviously the PWM from here, not from this one, which is the RPIM, but it is used for motors. So I am assuming, since I don't use the wiring PI, that this is hardware pulse width modulation as well. Other than that, code is being saved, so let's run it this way. Value maximum is 100. Increments like using hardware PWM, but that comes from this setup. Let's see what happens. Unfortunately, I don't notice any change at all. None. Absolutely no change. Or am I too impatient? That can be just as well, because I notice some rotational velocity changes. And I don't know where they come from. And let me observe closely. Also, I need to say that I have put it on minimal speed through the potmeter. So if I turn the potmeter away, then it just runs, and now the LED it is on a very low state setting, so the LED is off and the motor barely runs. But the barely running or the fast running I want with this value. Now it is off. The motor isn't running anymore. Can I reboot it using pulse width modulation? I cannot. Unfortunately, I cannot. So this means that I will have to go back to find out how it works. And the question is, did I apply the pulse width modulation anyway? Hardware wise. Am I mixing up the code? Also possible. Let's take another look at the hardware for now. Right now the motor runs on the lowest possible speed, caused by the potmeter. Pulse width modulation is running, and it is very doubtful that the pulse width modulation can control this motor this way. As said before, I need a different op amp, but before that, in the example that I've used, it is not said which voltage there is used, nor which motor, just a DC motor. Well, this is a DC motor. So if I change it to the maximum value, in this case of 100, which is, by the way, set to change duty cycles cycle, it is not quite sure to me which pulse width modulation version actually is used. I can of course try it and see if this works. Right now it does not. The motor still works, so that's not any influence. No, I should put it right here. Does this work? Right now it does not. And it is in the same lane as this LED, so let me put it to 100. It doesn't do anything, which tells me it is hardware modulation, hardware pulse width modulation. So I can put it back in here, and I can put it back in here. Is it working? Is it not working? Let me reduce the light. It is now on value of 100 and I don't see it burning. Let me for one moment turn the speed up. You can hear the motor. I guess I need something else, but I have to find out how to apply this code so that it does work, or I need to change the electric. Anyway, that's it for this new series of series of experiment. New code, doubtful result, but I'll keep looking because it is possible, just not with this, apparently. Thank you for watching. If you like this video and my other videos, please subscribe to my YouTube. You can also follow me on Twitter if you don't want to subscribe. See also my Instagram and website for more information. And this is certainly going to be continued. Bye bye.